interaction between simulation and robot that I think we should revive. And one of the things looking forward for robotics, and I did flag for people that I'm not going to talk primarily about robotics, but I think in the future there's going to be a thing called swarm robotics. It is already being pursued within the sort of defense world, and I could talk about some of that, those examples. But swarm robotics would be where you have multiple robots and that you're controlling them, or there's some ways that they make decisions collectively that allow for some kind of emergent result. So they could form a line. They could do a real world application is search and rescue. So you have some boat that has floated, has sunk off the coast. And how do you begin to think about searching? So there's ways in which the robotics might move from kind of individual robots to kind of swarm robotics across a number of tasks. But as I say, I'm not talking primarily about robotics. So I think that's one example. What we can draw from the robotics is what is it about the design that we could bring into classrooms in a kind of day-to-day way. So every classroom all the time. I love the pictures of the children on the left, so I included that partially for that reason. So the first question I would ask, if we look at an image of a classroom, what might be the most obvious feature, or at least one of the most obvious features? So lots of times people list things, but the thing that I would want to focus on, and that is the focus of this talk, is it's a group setting. I've coached soccer for many years. It's more like a soccer field with multiple players than it is kicking a ball against the wall, right? So kicking the ball against the wall is what I'll call tutoring approach. But this kind of group-based design, how do we do group-based design? I think part of what's successful about that earlier robotics task is there are lots of ways of participating in this. So educational design, if it's going to be successful and scale and have impact, needs to pay attention to the primary feature of a classroom, that it is a group context. Now, this comes back to the three Ps, and in doing this, I'm going to talk about possibility, participation, and pattern, and the different aspects of that relationship to generative design. Okay, this is the thing that I want to contrast with. Instead of designing for the group, we tend to do tutoring type tasks. Tutoring type tasks makes sense if you're doing a one-on-one interaction. So if you hire a tutor, you might expect them to ask questions like, what's 2x plus 2x? And then the student that's being tutored would try and figure out the answer to that and might answer that. And they would go back and forth like that. So this is in a classroom, what's 2x plus 2x? But I want to make the case that it actually breaks in a classroom. So if the teacher asks what's 2x plus 2x and one student sticks up their hand, the hope is that everybody's paying attention to that. But the reality is a one-on-one interaction, and there's no design for the other 25, 35 students in the classroom. There's nothing for them to do except the expectation that somehow they're going to be paying attention to what's going on. So this is a tutoring type design. It's only one right answer. In terms of patterns, you only get very, very limited information and only about that one student, which is really inefficient. In terms of participation, what are the other students really doing? Now, we would like them to be hanging on to everybody's words, but the reality is maybe they're not, okay? And so how do we solve that instead of the response from, because we have this tutoring image in our head as that's what education is about and should be done best, forgetting about all the places in which we do things in group context, soccer, music, dance, so on, including research groups. We try and sustain this form of questioning, this form of task. And what do? We use certain technologies like the Xerox machine. So now I can take the 2x plus 2x question and I can give each student simultaneously a really badly designed question, but nonetheless, I can give it to every single student and they can do their worksheet and they can turn it into me. The teacher is the only arbiter of whether they understand. So going back to some things that Brent said and others have said, who gets to decide what's right? It should be the students developing agency. Instead, we use the Xerox machine to maintain a certain kind of approach to asking questions. And that approach to asking questions, why it might be fine in a one-on-one situation, actually breaks in the group context. Now we can use chalkboards, and I'm going to use an example in a second, but the goal is a simple kind of right wrongness. Essentially, the teacher is the only person who can decide that, and that the upfront space, the social space, is controlled by the teacher. So you might invite a student up to work one of the problems, but you're actually not using it as a way for kids to share their ideas. So tutoring type questions, the possibilities are very limited. In other words, the way in which you can respond to what is 2x is quite small. And the question the kids always ask is, did I get it right or did I get it wrong? So this is kind of what can happen. It's a consequence of bad design. It undermines participation, possibility, and pattern of focus on patterns. Now, being aware of time, um, one of the ways that that shows up is the 2x plus 2x question. Another way that you can do this is make the answer, in this case, 4x, the question. So what do I mean by that? Instead of asking the kids what's 2x plus 2x, they can use a graphing calculator. This is a classroom, in the United States, the euphemism for underserved settings is fraction of the students that are on school lunch. This is a school where it's 100% school lunch. There's 3 first languages. It's a full inclusion classroom, so there are various range of special education interventions. So this teacher asked the kids to create things that are the same as 4x. Bye. And I want 5 of them. On the left are some examples of what they created within the first 6 minutes. So they're actually creating them. If you watch the video, which I put a link to, the examples get harder and harder. So it's almost like on a soccer field, somebody does something interesting, then I want to learn how to do it. Then I have to do something more interesting. And it sort of does that social dynamic that we do in every single realm of human existence except school. All right. By the way, this videotape was influential in Texas developing a product called Navigator that I helped work on as an outside consultant, because they said, oh, that's a reason that you want to build a network, because you want to have kids be able to share ideas. So there's a kind of tech development side to this. So before getting too much into the technology side, I wanted to back up a little bit and say, you can do this with the technology we can find in schools. In fact, slates, if they're there, you can use them. So for example, a 2-column addition problem. Nobody's going to argue that, that sounds sexy. It does not sound sexy. It sounds like the kind of low-level stuff that everybody hates. No, you can make it into something that's playful, to use some of the words that were there. So 32 plus 12 is a canonical example of a 2-column addition. There's kind of one right answer. You can ask the kids to get the right answer. The alternative with generative is to say, listen, I don't know what's behind these question marks, but I know it adds up to 54. Bye. I want you to come up with 2 or 3 things that could do that. Exactly the same mathematics. Exactly the same mathematics is being used to make it social instead of individual and alone. So one of my problems with individualized and personalized is it really means alone. And so what we're trying to do is say, no, there's this group around, and why not leverage that as a kind of feature instead of a bug? So if we turn it around, we can ask the kids to create things. They can come up with at least one. They can talk to their shoulder buddies, so this person next to them, about whether they think it's right or wrong, and talk to each other about the mathematics itself. And then the teacher can choose, or the kids can choose in a lot of cases, to put their examples in a public space like the front board. So no longer controlled by the teacher, but in fact, a place where we share our work instead of see how it's done correctly, right? And so even if you have enough room on the board, you have kids put all of their examples up. So in the same time that a teacher might go over one example, you actually have 30 examples on the board of likely to be correct responses. And the kids start to see the pattern, and that becomes an important thing in just a moment. So the patterns, if we look at the first round that you do something like this, and I'm aware of the time, so I'm going to try and cut this down a bit. But if you look at the patterns of what kids might do in the first case, all of these are right. Some of them are kind of humorous. You've got 4, 1, and 1, 4, and so there's a diagonal here. This might be somebody who has a kind of puckish streak that says 53 plus 1 is 54, and you go, yeah, that's right, and that's kind of funny. But so humor starts to appear because it's playful in the way that I think Brent was talking about. But there's a pattern. So if I'm a teacher and I look at these and I teach this stuff day in and day out, there's something that's missing. So there's a lot of good here. There's a lot of success here, but they didn't do anything with carrying. So you can do another iteration where you say, okay, folks, those were all great, but now I need at least one of the numbers in the first column to be bigger than 4. Bye. Bigger than 4 means that they'll say, how do you do that? You can't be bigger than 4 and add up to 4. You sure? What if I put 7 plus 7? Oh yeah, you'd have to carry the 1, right? So now we're exploring a kind of harder thing within a very basic set of mathematics in a kind of playful way, where again, you have the students create ones, talk to each other about them, and put them on the board. Much more efficient, much more mathematics is done in this playful way. So no longer, Brent, do we have to apologize for the time it takes time. We can actually say this time is more efficiently used if you leverage the group capabilities, right? So I think I've got a short period of time. Now, I've provided a bunch of links. There's a form of assessment here. So here's a 3-column edition that was done with, I think, almost 60,000 third graders. The distribution above is the different combinations of letter responses. So this is called pattern-based assessment, but it grows out of what I just did with generative design. So then you can create assessments that look for patterns